Watch closely. Anytime that you throw an object, its path will appear to be roughly parabolic. But if the object has an irregular shape, like this push stick does, its path of trajectory will seem somewhat eccentric. But there still is a parabola in there. You just have to know where to look in order to find it. This metal weight hanging from a piece of fishing string will create a plumb line. And since the object is free to rotate while it hangs on the nail, it divides itself into two halves, where there are balanced forces of torque on each side of the string. After a revision or two, you can find the exact spot where the line was, and then just connect that point back to the nail hole. Then we repeat the same procedure again with a different nail hole to find the point of intersection for the two lines. By the way, it doesn't really matter exactly where the two holes are located, but it's probably a bit easier to still be accurate when you use holes that are slightly far away from one another. And any additional nail holes should verify our findings. So it's useful to do a third one just to check. The point that we've just located is known as the object's center of mass. Sometimes it's also called a centroid in two-dimensional geometry. This point has some pretty unique properties. The push stick will balance on this point because its mass is evenly distributed all around the point. And when we give it a spin, the center of mass is the point that the object rotates around. Too fast to see? Watch it at 1/4 speed. So where's that parabola when we throw an object that has an irregular shape? The center of mass is the imaginary point that would draw out that parabola, if you could actually see it. I hope that some of this was interesting to you.